I'm Paxton O'Brien from the Science Show, and today I'm here with Dr. Tom Roberts. Hello, Tom.
Good afternoon.
And today there's been many questions going along about Newton's 3 laws of motion. And today Mr. Tom Roberts is going to be confirming questions about this. So, well, first, could you just tell us a little bit about yourself?
Yes, I work at the Jet Propulsion Laboratory in Interplanetary Communications. I have my PhD in optical sciences, mostly a combination of optical design and laser physics.
That is amazing. I wish I had the time for that.
Wish I did too.
So what is Newton's first law of gravity?
Newton's first law is that an object in motion remains in motion unless it's acted upon by an outside force.
Oh wow! So that if I just throw a ball out into the oblivion, then it'll just keep on going?
That's exactly right, unless it's acted upon by a force. That force, as we typically experience here, is gravity. So it's gravity that actually causes it to fall down to the ground eventually. But if you were sitting out in space where there's essentially no gravity, far from any massive object to give you that gravity, then the ball would just continue on and on forever.
Oh, that's quite interesting. Well, what about his second law of motion?
The second law has to do with, that's where it starts getting mathematical. It says that the force is equal to the mass times acceleration. So if you have a certain amount of force that's applied to an object and you know the mass of that object, you can exactly predict how much it will accelerate as a result of that force.
Wow, okay, so I'm going to pretend I understood that, but would you mind giving us an example?
Sure, here's an example. Suppose we have a ping pong ball and you want to blow on that ping pong ball, thereby providing us force to push against it and cause it to move away. You can blow against it and it moves away pretty quickly. But if you try doing the same thing with a billiard ball, which is much more massive, you blow on it and only a little bit of motion results. You have to blow pretty hard to make it roll at all. And that's because it's so much more massive. Therefore, because you're applying the same amount of force, the acceleration has to be much, much lower.
Okay, well, what about Newton's third law of gravity? Is that important?
The third law is very important. It says that, that for every action, there's an equal and opposite reaction.
So if I were just to push you or throw or just push this off, so it would just bounce back, or?
Well, it's somewhat similar to that. It says that, okay, if you're again out in space with no particular forces applying, okay, if you were to come up and push me, then I would go sailing off in one direction, but you would go sailing off in the other direction.
Oh, wow. Well, that is quite amazing, and I think that kind of confirms all of our questions about Newton's 3 laws of motion. So, wow, thank you very much, Doctor.
Happy to do it. Thank you.
Thank you for being here.
My pleasure. Good evening.
Thank you folks for being here, and come back next week for another episode of